The provided flow demonstrates the use of node-RED nodes like inject, debug, split, join, delay, and change. Here's an in-depth explanation of each section in real-time scenarios where these nodes can be useful. Basics. Section. This section includes a comment node for labeling and a group of nodes. Inject node sends a message with a specific payload at a scheduled time or on demand. Here it includes a custom property, test, with a value hello world. Debug node displays the output message, MSG, in the debug pane. Let's see the real-time use case. Debugging flows. The inject and debug combination is widely used for testing and debugging. For example, simulating input data to test an API integration. Viewing message payloads and properties for troubleshooting. 2. Delayed debug section. Inject node sends the current timestamp as the payload. Delay node introduces a 5-second delay before passing the message to the next node. Debug node displays the delayed message in the debug pane. Real-time use case, rate limiting or sequential processing, implementing a delay to control the frequency of requests sent to an external API, simulating real-time delays in message flows, such as emulating network latency in IoT applications. 3. Split join section. Inject node sends an array of objects, each containing op1 and op2. Split node splits the array into individual messages, one for each object. Change nodes perform calculations for each object. Calc sum adds op1 and op2. Calc product multiplies op1 and op2. Join node combines all processed messages back into a single object. Debug nodes show intermediate and final results. Real-time use case, batch processing in IoT or data pipelines, splitting sensor data, example, temperature and humidity readings, for individual processing. Performing calculations like sum, average, or other analytics on batch data. Joining processed data into a single structure to send to a database or visualization tool. Fourth object, splitting and handling. Section, inject node, sends an object, example, temperature, 25, humidity, 60. Split node, converts the object into individual messages for each key value pair. Change nodes, process individual parts, and additional nodes, not detailed in your flow, can handle this data further. Real-time use case. IoT device data. Parsing. An IoT sensor sends a JSON object with multiple parameters, example, temperature, pressure, and humidity. The split node helps process each parameter individually, such as triggering alerts when temperature exceeds a threshold. Why use these nodes? 1. Inject. Automates the generation of test data, simulates events, and triggers flows at specific times. 2nd, debug. Essential for monitoring and debugging flows by showing real-time outputs. 3rd, delay. Implements timing controls and rate limiting in flows. 4th, split and join. Split large messages, arrays, objects for granular processing. Combine data streams for structured outputs. 5th, change. Transforms and processes data dynamically. Comprehensive real-time scenarios. 1. IoT data processing. An industrial IoT system receives data from multiple sensors. You use split to handle individual sensor data, calculate averages or other metrics, and join to send summarized data to a dashboard. 2-point API integration. A flow fetches multiple records from an API as a single response array. Using split, you can process each record, example, validation, enrichment, before sending it to a database. 3rd, data transformation and pipelines. In a supply chain application, an array of product data is split, processed individually, example, calculating discounts or applying taxes, and joined back for reporting. 4. Dynamic notifications. A home automation system splits an object containing various room temperatures, processes each to check thresholds, and sends notifications if a room is too hot or cold. By combining these nodes, you can design powerful, flexible, and reusable node-RED flows suitable for diverse real-world applications like automation, IoT, and system integration.